division. This is called a what? This is called a mixed number, right? So what mixed number, wouldn't be mad at. But then you learn this. You could actually do this as well. And actually, this is later. Like, that was the first thing you did, is call the remainder. You made a what? Decimal. What'd you put after this decimal here? A 0. What'd you do with this 0? Brought it down. And then, how many times 4 go into 10? 2. 2 times 4 is... And then subtract, and what do you get? 2. Isn't this fun? Okay, then you put a what? 0. And a blah, blah, blah. And then, how many times 4 go into 20? So these are equal. All right? And actually, these are all equal to 13 over 4, which is what you did. You did 13 divided by 4. What's 13 over 4 called? Improper fraction. But the reason I did this is not because of Mickey Mouse. What's going to happen today? You know what that 0.25 tells you? It's related to the, answer that, what is that called? The remainder, actually. It's the remainder divided by the divisor. I want you to remember this for what we do at the end. So couldn't I take the decimal and multiply it by the divisor to get the remainder? That's what we need to remember at the end of this lesson. If I take 0.25 times 4, what is 0.25 times 4? 1, and 1 is the remainder. Okay, so just recall that when we go to the end of this lesson. Okay, and then I'm going to write this in a silly little division algorithm. I told all my classes all day long, a smart thing for you to do. I was talking to the other teacher, like, hey, maybe we should do a Google Doc. You know, and then the students fill this in, but then I guess only one student would fill it in and all the rest would copy it. Right? You really should be in this class. It's not the math. All you did is multiply and add yesterday. What you had to figure out was what the patterns were. And then maybe some terminology. So a separate sheet of paper for each chapter. You should start building a vocab and notation situation. I'm just telling you how to be successful in this class, because that's the only thing that's going to be weird. What does this notation mean? How do I do it? And then it would be a little review at the end. Maybe a brief example. And every little thing would have like 1, 2, 3 lines with it only. Keep it small so you just have little reminders. Just telling you how to succeed. And actually the same thing would happen in college. Because you're on your own. No professor would ever tell you that. Because they don't really care. They're just caring about getting it out there, and it's your responsibility to get it. So, here's what this is. All right. These are terms that we should already know, but I know the reality of it. They're not terms you use every day, so you don't, probably. Dividend. Dividend is the word for the number that is being divided apart. The number underneath the garage. And actually, I'll write this with the previous Mickey Mouse example that we did. Another term, divisor. Divisor is what you're dividing by. Q is easy. Q is quotient. I'd be sad if we didn't know quotient meant the answer to the division statement. And then R, I'm not even highlighting that. What's R? Remainder. So let's look at that last question and write it in this format. Well, I can't really see it. Maybe I'll zoom back just to make the notes look, all fantastic. 13 is the dividend. Doesn't that equal the divisor times the quotient? By the way, what's 4 times 3? 12 plus 1. And then what I'll do is I'll go back and highlight this in the appropriate colors that I highlighted down there. Sometimes color coding works as well. Is this something we're going to have memorized? No, but it's common sense, that this is true the way they wrote this. Now let's look at this other 15 divided by 5. What is the answer to 15 divided by 5, by the way? 3. What's the remainder? The remainder is what? 0. So now this is this last thing. And this is the kind of thing that you would write in your vocab / symbol recognition. I'm just the informant. That's another thing I give myself, freedom from your scorn. I'm just giving you the information of notation that I just learned a couple days ago myself. If we say M divides A, we write it like this. Really what they should say is M divides A, E, V. Come on, it's like playing Wheel of Fortune. EV, evenly. What does evenly mean? Remainder of what? 0. So we can say M divides A if the remainder is 0. It's going to be written like this. M divides A, right here. So that last example, we could say 5 divides 15. And that we could take to the bank. We cannot say 4 divides by 13, divides 13. That's false. Fumble. The answer's all in front of you. Is 13 divides 543 true? All you have to do is do what? Divide them. And then see if there is no, wait a minute, no remainder. How do I know this has a remainder? There is a decimal. There's a decimal. Are you okay? There's a decimal here. All right, now this is what I just said about that 3.25 and 3 1/4 question. What if for giggles, I wanted you to tell me what the remainder would be? Well, all you have to do is take this decimal and multiply it by what you divided by. Because that's how much of a 13 you missed. You were that much short of a 13 of going in. So if I take that decimal and multiply by 13, you get, why do we get 9.99999? Why does that happen? Okay, and I'll let that sit out there. All right, they got it. I don't know if I put that on the movie. We covered a lot of important stuff offline. Well, hold on. All right, so I think offline I talk about how getting the remainder this is, and then basically what I did before on that other one. Not that you have to do this today, but this is all true. 543 divided by 13, of course, is 41.71. We did that, but it's also 41 and 10/13ths. And you can flip this around and take 10 divided by 13, and you'll come back with that decimal. But again, from the decimal, we got to know how to find that stuff. Yeah, blabbering on. Can't be talking about movies anymore. Can everyone say modulo? Modulo. Okay. In this next chart, I'll be 100% honest. This blew my mind. And it took me a while to figure out one simple concept because mathematically it doesn't click with me until I did what I'm going to do with you. So you really need to focus. These are just division by 7. This is what they decided. They had to pick something to divide by. They picked divide by 7. All right? And then the remainder, when you divide by 7, can only be 0 through 6, right? You can't have a remainder of 7. What does that mean? You just didn't go what? Like far enough, right? So if you have a remainder of 7, when you're divided by 7, one more 7 should have went in. I hope that made sense. That's just basic stuff right there. So the division algorithm for integers tells us that the remainder will still be a whole number, less than or equal to 6 for divided by 7, even when a negative integer is divided by 7. Psh, that's the mind blower. So here, let's take a look at this chart, and the reason I put it on here is to hack this apart. I have no problem with these numbers whatsoever. These I can figure out. This is the remainder off to the right. What's the remainder when 7 goes into 7? Well, 7 goes into 7 what? Once. What's the remainder? 0. 7 goes into 14 twice. What's the remainder? 0. Take another one. 18. 7 goes into 18 how many times? Twice. But what's the remainder after that? 4. No problem, right? You can do all these in these positive in that realm right here. Then they got a little bit of a more of an issue here. Wait a minute, 7 doesn't go into 0. All right, 7 doesn't go into 1. How many times does 7 go into 0? 0 times. What's the remainder though? 0. The remainder is 0. How many times does 7 go into 1? 0 times. What's the remainder? 1. So, okay, that's a little strange to talk about it that way, but it is true. The 7 goes into 1 0 times. The leftover is 1. I see some brains about to explode. Oh, just wait. This is going to be awesome. I have one question and one question only to get you to understand the next part. Who's bigger, negative 15 or negative 10? Very simple question. Who's bigger? Negative 10. So let's go back to this and word this way, and this is why this happens over here. 18. What is the multiple of 7 smaller than 18? Closest to it. 14. And then how far away is 18 from 14? 4 spaces, remainder 4. Negative 10. What is the smaller multiple of 7 closest to negative 10? Negative 14. How far is negative 14 away from negative 10? 4. It would have a remainder of 4. Negative 12. What is the smaller multiple of 7 by negative 12? Negative 14. How far away is negative 14 from negative 12? 2. Negative 15. What is the smaller multiple of 7? Negative 21. How far is negative 21 from negative 15? So it has a remainder of 6. That's how you have to do this in order to figure out what's going on. I'm done with that. The new word for today is modulo. When numbers have the same remainder when divided by 7, they are said to have a congruence modulo 7. That whole chart was all based off of divided by 7. I'm going to say that about 4 more times. When numbers have the same remainder when divided by 7, they are said to be congruent modulo 7. When numbers have the same remainder when divided by 7, they are said to be congruent modulo 7. One last time. When numbers have the same remainder when divided by 7, they are said to be congruent modulo 7. So again, the modulo could be anything. It could be mod 5, mod 12. When numbers have the same remainder when divided by 4, then they're said to be congruent modulo 4. The modulo can change. I just started with a 7 example to do this. Now watch this pattern, and it should be pretty easy to figure out. Same modulo. What's 21 minus 14? 7. And that difference is divisible by 7. 24 minus 10. What's 24 minus 10? 14. 14 is divisible by? Or 7 divides that. That's we're going to use that notation from that thing. So the pattern that develops on these, no matter what row you look at, when you take the difference between two numbers that have the same remainder for 7, that difference will be divisible by 7. It's a natural progression, even with negatives. When I take 27 minus negative 15, be careful. What's 27 minus negative 15? 42, and 42 is divisible by. Now, what it doesn't tell you is what is the remainder. It just says they have the same remainder for this modulus. Okay, so again, wax on. I see your faces. What? So, in conclusion, the quick check for this to see if A is congruent to B mod M, modulus M, it doesn't always have to be 7, is to take the difference between the two numbers and see if that difference, see if 7 divides that difference. Remember this notation. This means M divides B minus A, which implies the remainder has to equal 0. Now, I am going to inform you of both parts before we do each example, but I'll stop for a second. Son of a nutcracker, I got to do that over. I didn't tape that. All right, what's the remainder when 7 goes into 38? Say it. 7 goes into 38, what's the remainder? 3. 7 goes into 66, what's the remainder? Same remainder, so this modulus is going to check out. When I take the difference between these two and then divide it by 7, I get no remainder. That means this mod is true. All right, let's do that again. What's the remainder when 5 goes into 12? 2. What's the remainder when 5 goes into 54? 4. Not the same remainder. Watch what happens when I take 12 minus 54. I get a decimal implies there's a remainder. And that goes back to my original, right here. All right, remainder. I could take this decimal and multiply by this and get that remainder. Decimals relate to remainders. And I'm going to do one more of these. I'm okay, nobody worry. Sometimes don't include me in that, Mr. S. Sometimes we want to find a number from 0 to m minus 1. What's m? What we're dividing by. Remember what I said? If we're dividing by 7, the remainder has to be what or less. If I'm dividing by 7, the remainder has to be what or less. 6 or less. Answer the stinking questions. All right, 6 or less. So that's all that means. So why? I'm probably only have time to do one of these. No, I have time for 2. Why would I take this if I have to find this and find out what the answer is by dividing? Actually, does anyone know what the answer is? Just raise your hand if you know what the answer is, because the answer actually sticks out like a sore thumb. Who said? Raise your hand, sir or ma'am, or whoever said that. Who said that? Who said it?
That was not me. That was him. I don't know this stuff. That was him.
Did you say it? No, someone said 2. Why are we fighting? Hold on, we have an incident. I gotta stop a fight. So the fight was, and the answer was said correctly, but they're fighting that the other person said it like they don't want the credit. It's so strange. The answer is 2. Why is it 2? What's the remainder when 5 goes into 132? 2. So they want this to be the smallest number possible in this position, when in fact there could be a blank number of numbers that belong in that position. Does anyone know the answer to that? Starts with an I, N, F. Okay, infinite. So here's what we could do mathematically. We could do that whole remainder thing. We could find the remainder by actually physically dividing these two numbers. What did we get? I think it was 26.4. What did I say 0.4 can help you find? The remainder. Take 0.4 times 5, and you get 2. So according to the directions, they wanted, for question mark, only the number that's between 0 and the smallest possible remainder, which is 2. And then we could say, all right, I get it. When 132 is divided by 5, I get a remainder of 2. When 5 divides into 2, goes in 0 times, but it does have a remainder of 2. All right, so that's the answer. If I didn't have those silly conditions, what else could be here? We could put 2 there. We also could put what? Come on. You skipped one, but he's right, 12. He's messing with me. What's between 12 and 2 that also could go in that position, which would be a valid answer for this mod? 7. 2, 7, 12. What else? Keep going. 17. What's up? What else? Let's go backwards and blow our minds. 2, let's go backwards. What else could go in there? -3, and they would all fit this pattern. 2 minus 132, which is -130. Is -130 divisible by 5 with no remainder? Yes, but it's also about the numbers having the same remainder to begin with in the positions. According to the directions, though, they wanted the smallest possible positive one only, which is the 2. So 5 goes into 2 0 times with a remainder of 2. But there is an infinite amount of possibilities if we did not have that set of directions. Alrighty then.